Okay. Hello and welcome to another episode of Vector Space Talks. My name is David Muriel, and today we've got a truly fascinating conversation lined up for you. Imagine an app that could tell you which celebrity you resemble the most, powered by cutting edge AI, face recognition embeddings, and vector search. So, whether it's for fun, social buzz, or exploring the possibilities of machine learning, this app revolutionizes how we think about similarity and connection in the digital age. So, to take us behind the scenes, today we're happy to have Miguel join us today. Miguel is the brilliant mind behind this Twin Celebrity app, a project that seamlessly integrates open source technologies into a user friendly experience. And in the comments below, we're going to link to the app in the repository that you can use to build it yourself, and we'll have a short demo in this presentation. Miguel's work combines the power of AI with creative use cases, which proves that machine learning is not just used for solving complex problems, it can also be a ton of fun. So, Miguel, thank you for joining us today. Let's get started.
Thank you very much for having me, David. Thank you very much.
Um,
It's a pleasure.
Thank you. And I watched your video, your demo a few times. It was really exciting. I started a Google Cloud project the other day to make it work myself. I didn't get such a great result. I don't know, my face may not be as beautiful as yours, so I don't necessarily want
Thank
to
you.
show who it was, but I do have some questions for you.
I'm curious about it, by the way. Who is your celebrity match?
I'll show you a little later.
Okay,
Okay, I got a first one for you.
perfect.
So actually, did you want to do a bit of an introduction and explain what the app is and how it works?
Yeah, if you want, right now I can give like a general introduction and then we can go through all the different components and the diagrams, etc.
Yeah.
Okay, so the app is, as David, as you mentioned, is an application that tries to emulate many of these mobile apps that you find sometimes that they tell you like what is your celebrity match, etc. And the other day I was in my Play Store and I realized that using vector databases like Qdrant, for example, it shouldn't be so difficult to emulate these apps. And in fact, I guessed that it will be really fun, like a really fun experience. And if you check the demo, I mean, it's you can build the whole project in under 1 hour or less. So that was one of the motivations. Like, let's try to build one of these twin celebrity applications, but using open source, as you mentioned, an open source embedding model and Qdrant Cloud, which in this case was for free. So without you just need to waste a bit of money in Cloud Run if you want to deploy everything to the cloud. But if you want, you can also host everything on your local machine because it will run perfectly. So yeah, that was like the whole motivation, just trying to explore some cool and fun applications using the power of embeddings.
So, when we think about real world use cases of facial recognition and face matching with various celebrities or known faces, can you think of some problems you could solve in the real life with this type of mechanism?
Yeah, for example, for security applications, suppose that sometimes we need to, I don't know, to use our ID for some security doors and stuff like that if we want to get into security buildings, etc. So one of these applications, one application of this technology could be to use a lot of our faces and define like an embedding, like a vector of our face based on multiple photos, multiple pictures of our face, define one embedding for us, like an average embedding. And if you take another picture of yourself, just check the similarity between the new picture of yourself and your average embedding. And this way, you could implement some security measures. Like if you are not close enough to this average embedding of yourself by a threshold, then it will mean that someone is trying to bypass the security measure or someone is trying to impersonate you. And this could be used for unblocking your mobile phone, for unblocking your credit account in your bank account, getting into some building, or in the airports when you want to pass your ID or your passport, things like this. I really like the fact that with embeddings you can generate an accurate representation of yourself in a vector space in terms of your face.
Absolutely. And I think this really leads us to your to a discussion about your choice of components, because you have to
Yeah,
choose the right stuff to get the highest precision. So, could you walk us through the architecture of the app?
sure.
Just to describe how all the components, I think you're using FaceNet for embeddings,
That's it.
Qudrant Course for storage, ZenML as the framework, and Streamlit for the front end.
That's it.
Perhaps you can even share your screen. You can show us how it all works.
For sure. Let me show the screen. Okay. So let me know if you see Excalibur right now. You should see some diagrams.
Yep.
Okay, perfect. So this is an overall diagram of all the application, and then we will go into the embedding pipeline, which is like the core. All the code is based basically in this embedding pipeline, but I will give you like a very overall overview of the diagram. So first of all, we have this offline block that contains some code that is going to be used just one time. Of course, if you want to, for example, add new celebrities' faces, you will need to run this offline pipeline again. But what this pipeline is going to do is to take a bunch of celebrity faces. For this proof of concept, I was using 3,000 celebrity faces. And for each celebrity, I was considering around 20 or 30 pictures. So you will have 20, 30 pictures for Brad Pitt, 20 pictures for Angelina Jolie, for Hemsworth, for Josh Clooney, etc. And then you will use FaceNet. In this case, it's a ResNet inception model that will take each one of these images and it will generate an embedding. It would generate a vector of 500 dimensions, more or less. And this embedding, this vector, is going to be inserted into Qdrant Cloud. In fact, if you go here, I have here the database that I use for the cluster, that I use for my demo in YouTube and also in LinkedIn, all the posts that I've been generating. And here you have all of these embeddings represented in the Qdrant application. And if you take a look at the label, you will see that the clusters are already present here, and they are really easy visualized. Like for example, if you go here to this region, you will see this is the cluster belonging to Elizabeth Olsen. This is the cluster belonging to Sophie Turner, and this for Sarah Wayne Callies, Natalie Dormer, Anthony Mackie, Margot Robbie. So what I was trying to do is to take all of these images, and this was really nice because I realized that what I was expecting happened in reality, that all of these clusters are accurately representing the face of a celebrity. Okay, and what I will do, let's go back to the diagram, is to, when I take a picture of myself using the Streamlit application that you mentioned, David, this picture of myself, this selfie, is going to be transformed into an embedding using the same model, ResNet embeddings, and I'm going to take the cluster that is closer to my embedding. In this case, I spoiled the surprise of the YouTube video because in my case, it turns out that it's Andy Samberg, and yeah, but basically it's a problem of similarity measures between vectors, and that's it. It's really simple, but of course, as you mentioned, you need to select the correct models for generating the embeddings, basically.
So, face. I think when you look at the benchmarks,
Yeah,
FaceNet is somewhere up there with ArcFace. However,
yeah,
there are certain aspects to this model. I think also it has to do with being lightweight, being able to be deployed
yeah.
on edge devices, like you said about facial recognition on mobile devices and things like that. Did you consider any of this, or were you
Yeah,
strictly looking at the benchmarks?
for sure. I was considering also all of these constraints because I wanted something that should be run in my Cloud Run application without using any kind of GPU. For example, this is CPU based, and that was something that I really wanted when I started the project. I didn't want to rely on any GPU. I just wanted something light and possibly pre-trained with a lot of previous images because I didn't have enough images of celebrities. So I had to choose something that was pre-trained and also that was lightweight and that could be run in a Cloud Run in a very tiny container that I was publishing in Cloud Run. And in fact, here you can see that I'm using just like an embedding model, but in reality, I'm using two models. One is this ResNet, where I take the image and generate the embeddings, but there's another model before that is MCTNN that I use. It's some kind of convolutional neural network that I need to use to recognize and to detect the face and to, draw a rectangle on my face because maybe, I mean, you can be in different positions in front of your camera, but the model is expecting like a front image of your face. So independently to how you took the picture, this model, this MCTNN, this convolutional neural network, is going to take exactly the type of picture that the ResNet model needs. So that's
if you look at one of the sample images, I see one guy wearing a suit and his face is kind of in the background. So this
that's it.
first model,
This one,
the first pass would basically, that's the Winter
that's it.
Soldier,
It will
Sebastian
do something like this. Yeah, it's Orlando Bloom, I think.
Orlando Bloom. Sorry.
Yeah, it
In
will
any
do
case,
this.
you would make that rectangle first, and then once all the faces are lined up, then you would run it through the embedding
That's
process.
it. That's it. Exactly. That's it,
And
basically.
I just want to mention one thing for people watching this. So, the choice of the embedding model is obviously extremely important, but one of
Yeah.
the cool things we can do with Quadrant is we can actually visualize how closely related things are. So you can go to that visualization tool that you showed us a second ago, and those clusters, I mean, the embedding model is able to tell traits like, maybe gender or hair color
Yeah.
or eyes, how close the eyes are, how big the nose is, and it'll cluster people together
Yeah.
based on these kind of hidden features. So you, as a person doing the embeddings, before you even make your app work, you can check if it makes any
That's
sense
it.
in the first place.
That's it. That's what I loved about Qdrant, the ability to check this similarity. And as you mentioned, just before I start like deploying all the Streamlit application, etc. That's really nice. And yeah, and it's surprising because as I mentioned, this is a pre-trained model. So this model is possible that it has never seen any of these images before,
Yeah.
but it is able to generate really accurate clusters of each one of the celebrities, and that's really really cool. In fact, I don't know if because it depends on the type of images stored, and I like generated a lot of batches. But I remember one time that I saw two clusters overlapping, and I was like, "Wow, this might be something wrong with the embedding model." But then I checked the images of the two celebrities. I remember one of them was Emma Watson, but the other one I don't remember. And if you check the original pictures of the two celebrities, I mean, they were basically the same. They looked like twins in reality. And that made me think like, wow, the embedding model is doing a really good work because me as a human, I'm seeing these celebrities as almost twins and the
Yeah.
clusters are overlapping. So that was really, really cool. And that's when I realized that the embedding choice was the right one. It was working as expected.
It's scary good. It is. Have you tried the other visualization feature we have? If you go back to the collection,
Yeah, this one, the graph,
yeah, have you tried
right?
sampling? You can sample like let's say 900 or 500.
Yeah, let me check.
So limit is just 5. No, 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 that's
Yeah,
wrong.
I tried this. Yeah,
No, no, no.
that's
So go limit 5
yeah. Let
and
me
then
try maybe 20
comma,
or something.
comma, and then the next parameter. You have to give 3 parameters. So limit 5 and then sample, let's say 500. So no, so you have to go, it's like a JSON file. So you have to go below.
Ah, okay, 5.
5 comma, sample, 500, comma, tree, tree as in tree true. So you have to create a tree graph and
Okay,
try to
like
run
this.
that. Yeah, so what is it?
Let me. It's just removing this comma. That's it.
There you go. You can
Yeah,
pull it
this is really
apart.
cool.
So you can pull the nodes apart. If you can zoom in and you can see your
Yeah, this is
clusters
cool.
bunched together a lot. You can
Yeah,
see the connections between individuals. Now,
like
we
for
use a
example
few
here.
examples. Yeah, we use a few examples where there are images attached to the payload, but I think you can just look by the name in the payload. So Alexandra Daddario.
Yeah,
Um, yeah, I guess
yeah,
she's got a few
Hefir,
pictures. Yeah,
Alexandra Dada. Yeah, there are like around 20 pictures of each
okay,
celebrity, more or less.
I see.
Like Alessandro Dario. Yeah, this
Yeah,
is really, really cool. I mean,
yeah.
this is really cool.
In any
Let me
case,
check.
maybe it doesn't suit necessarily the best this data set because there's repeating entries, but there are other ways of visualizing as well.
Yeah, this is
I,
cool.
uh, I do want to ask you another question that I have. So you said that, because you were learning Rust, and Quadrant is, of course, Rust based. Um, can you really tell us why you chose Quadrant for vector similarity search? There are a lot of options, right?
Yeah,
There's ways just using a regular database and adding vectors to it. So,
yeah,
yeah, could you give us some of your kind of top three reasons why you chose Quadrant in the first place?
yeah, for sure. Yeah, one of the reasons, and I mentioned that to you before, is that I was learning Rust at the time, and I really loved the fact that Qdrant was built from the inner ground in Rust. The second one was that I started, I remember that I was really interested in quantization measures and how you could store embeddings in an efficient way, because many times we are dealing with float type vectors, and that will entail a lot of memory consumption and also a lot of disk usage. And I was really interested in all the different techniques that you can use for quantizing all of this information. And that's the moment when I realized and I noticed a lot of high quality tutorials in the Qdrant documentation about the different types of quantization methods, like binary quantization, etc., etc. And I really enjoyed that documentation, that article. And I remember that I started using Qdrant for my personal projects. And then I really loved how Qdrant Cloud works. I mean, when I started trying the different options of vector databases, I tried Pinecone, I tried also Weaviate, and yeah, and that was it, I think. And I really enjoyed all of these capabilities. I mean, I find out that it was really easy to work with Qdrant and to create a very simple cluster in Qdrant and to integrate some Qdrant databases on my projects. And for the other vector databases, sometimes it was a bit harder. Maybe it was because they were, I don't know, in earlier stages, or the documentation was not as complete as in Qdrant. But I felt really really confident and really really happy with Qdrant from minute one. I mean, it was really cool to work
You
with
know,
this. And
you talked about quantization, and this is kind of interesting. From the get-go, when I started working with binary quantization, I never thought it would be appropriate for uh, very specific visual recognition use cases. For example, checking the moles on your skin, the shadow
yeah,
of the ground, and all of that stuff. When you're using quantization, you have to compress your data, right? So you're losing
yeah,
some of the quality. And as a scientist, you're trying to find out if something is dangerous from a health perspective, you need to check the right shadow, the color, and all of that.
yeah.
Um, if we're gonna go and do a visual recognition kind of thing like this, do you think quantization would be appropriate once you move to like a data set like 20,000 pictures, or would you rather stay away?
I think that I would try to stay away if you are trying to make something really really accurate. But maybe, I mean, if you are trying to detect the similarity between like one picture, yeah, a picture of yourself, and this cluster of pictures representing a celebrity, maybe you don't need that accuracy, so
Yeah.
much accuracy, because at the end of the day, you are just trying to select like a similarity score between like average vectors, etc. So yeah, maybe you don't need that much accuracy. If you, of course, if you are dealing with like medical diagnosis or things like that, then for sure you will need a lot of accuracy, and that for sure. But in this specific case, I think you could probably work with some of these quantization techniques. Yeah.
Yeah. There's also scalar, which is a lot milder. I don't know. I
Yeah.
think ultimately it comes down to you have to test out the precision. So you would go ahead and try things out for yourself. I don't know if I can prescribe any advice when it comes to
Yeah.
this.
Yeah, probably. Yeah,
Yeah.
and you will have to compare. Probably I will compare like first of all start with the original representation, then go back to I don't know like scalar quantization, and finally to binary quantization, and you can check like the different approaches and the results that they are giving.
Yeah, absolutely. And so what additional features or improvements are you considering for this? So would you think of things like video input or adding a bigger data set or fine-tuning the embeddings
Yeah,
or for
yeah,
regional
you
diversity?
yeah, that's it. I mean, you have mentioned two of my ideas already. So yeah, the first one is to increase the data set size because I was dealing with I think I mentioned like 3,000 pictures of celebrities, and I have a very limited collection of celebrities. So there are a lot of celebrities missing. Like for example, I didn't see one actress, sorry, that I love, which is Jennifer Aniston. For example, I have no pictures of Jennifer Aniston, and that's something that bothers me a lot. And yeah, I will need to increase a lot the size of the database and the variety of celebrities that I am considering. Apart from that, I think I also love the idea that you mentioned about fine tuning the model because right now I'm using a pre trained model. As I mentioned, I'm using two models. So the first one, the MCTNN, I don't think that's necessary. I mean, the fine tuning process for that one because it works remarkably well. But for the second one, for the embedding pipeline, probably I will need some fine tuning, probably, or even attach some additional layers on top of the embedding generation for generating like a classification task, something like that.
Yeah.
And the third one that I was considering, like the third improvement, is that right now I have developed a Qdrant application with an Streamlit interface, but I think that maybe you can correct me because maybe I'm misjudging this, but I think this kind of applications, like it's better in a mobile phone, like you take a picture of yourself, it's much easier that having to develop all of this and
Yeah.
deploying this into your laptop because people are always with their mobile phones, and I think it will be a better fit for a mobile app. So something done with Flutter instead of Streamlit or something like that. So yeah,
So
that's
you would
another improvement.
basically, you would just, I can take my phone, you would just take a selfie, and then
That's it.
the next screen would just show you right away.
That's it.
Yeah,
That's it.
yeah, that makes sense. But I have to tell you, even though this is fun, this is very serious. I mean, the results are very precise. The system works really well, and people are eventually going to be using this facial, or they're already using facial recognition for production level applications.
Yeah.
Now, I don't know if you've considered this, but what would be like the biggest thing if a person's looking to move to production? Forget about the Streamlit and all that.
Yeah.
What is like the number one consideration from a production perspective that you would advise if you were like a consultant or something to a corporation? What should they do after they make this prototype work to really go big?
Okay, so for me, the bottleneck of this project is the embedding generation because I was generating everything, as I said, with just one tenant in ZenML Cloud, and I wasn't employing any kind of GPU instance. It was just a CPU, and sequentially, like generating. I mean, you have one image and you generate embedding, and you store the embedding into Qdrant. So I would go big and probably design some kind of multi GPU system that is able to process millions of images in a very fast pace. And also having a bigger Qdrant cluster where you can store potentially millions of embeddings representing your celebrities. I was even considering a way for this application to be sustainable in production, that instead of storing, like we did here, different images, just storing the average embedding per celebrity.
Oh,
So
that's
that,
interesting.
yeah, I think that's better, because if you have, imagine right now I was using 20 images per celebrity, but you could, I don't know, you could process 200 images per celebrity, but instead of storing the 200 images, you could just store the average or the median or whatever metric you find useful for your use case, but probably the average embedding. And you could reduce a lot the number of vectors that you're going to store in Qdrant.
And when it comes to frameworks, would you use a ready-made framework? Would you code your own things from scratch in production? How would you go
I
about
would
it?
probably stick with something like ZenML, because I really like this framework, because it has like for me two great advantages. The first one is that your code is much cleaner and much more maintainable, because you have to follow all the step and pipeline philosophy. You define different steps for a pipeline that you're going to run, and the code is much cleaner. And at the same time, it has different connectors, or they call it stacks, where you can deploy the same code to Amazon, to Azure, to Google, to whatever cloud provider you want. So I would stick with something like that, because you can reuse the same code in multiple providers, and your code will be portable and it will be really easy to maintain. I will
Makes
go with
sense.
something like that. Yeah, or Kedro, SNML. There are like different options that you could use, but I will stick with something that forces you to create high quality pipelines.
Before we start talking about you and your other projects, I do want to close this off by telling people how they can do this on their own. So there is a repository people can clone, but there are a few other things they need to consider before they launch this app, whether locally or I guess on the cloud. Is there something that you want to let people know they should pay attention to?
Yeah, for me, for starting with this project, I will pay special attention to Google Cloud Platform, and to create your project and be sure you are more or less confident, because I have it here, but we will be dealing with things like Cloud Run, and also with Cloud Build. So this is something that I'm not. If you go to the repo that I think you mentioned, it's going to be on the comments. I'm not getting into details about how to use Cloud Build, or what is Cloud Run and how to deploy things in Cloud Run. I'm taking for granted that the people that are going to use this repository, this project, are already familiar with cloud services, and they know like how to use, or not how to use specifically, because maybe that's not the case, but how I mean, they are familiar with things like CI/CD and what is a container, what is
Yeah.
Docker, things like that. If you are not familiar with that, then this project might be a bit complex. But
Yeah.
if you are okay with that, then it's going to be easy peasy.
Cool. And they can do the same thing on Azure and AWS. They might have to
That's it.
modify things a bit. Yeah.
That's
Okay.
it. That's it. They can
Okay.
fork the repository. Yeah.
Perfect. Well, I do want to give you a chance for the next little while to talk about your projects and your organization. I took a look at the stuff that you're doing, and I think you started a consultancy business, or is it a company that sells a product? Can you tell me more about your what you're currently doing?
Yeah, the neural maze. So, I mean, it started as a YouTube channel. To be honest, that's when I came up with the name, the neural maze. But then, yeah, I have migrated this idea into a mixture, like a hybrid between consultancy, which I do as a freelancer for companies, but at the same time, I also want to orient this initiative into the learning, like teaching how to build end-to-end projects like this one, because I find like there's a huge gap between all the different tutorials and things that you can find online, and the real deal when you come to some production ready applications. And that's exactly the thing that I want to put more focus on. Like, instead of teaching you the basics of neural networks, for example, teaching you how you can deploy these neural networks into Azure or into Google or into Amazon, things like that. That's exactly some of my intentions with the neural maze. And also, I would like to teach people about all of these new trendy and sexy topics like agents, like fine-tuning LLMs, because sometimes it might feel like it's overwhelming, the amount of information that we are receiving on a daily basis. But what I try to do is to reflect a little bit and to try to decompose all of these sexy topics into the basics, which surprisingly, it's really simple. I mean, for example, the concept of agents, that's something that I have been studying for quite some months. And it seems to be like really difficult to understand at the beginning, but when you understand what is happening under the hood, it's so simple. I mean, all the like tools like RAG, reflection agents, React technique, it's everything is really simple, and that's what I'm trying to do with the neural maze.
This is really interesting because I think the reason why this project is so attractive is because it's really easy to figure out what's happening, even to an untrained audience. And as we're seeing with the industry right now, a lot of people are learning. They're doing a lot of self learning. They're taking courses online, or whether they come from the industry or maybe they're established already as a data scientist or a machine learning engineer. But there is, as you say, a massive gap because the products are just being made, right? We can't know what they are and how to work with them if they've been created last week.
Yeah,
So on our side, we do this all day. We're trying to tell people how to work with it in a simple way, but it's never that simple. You go on these documentation sites and you see like, I don't know, you see like these notebooks that keep breaking. The Python notebook is good for 1 week and then it breaks the next week.
yeah, totally.
Um, so when you meet people who are beginners, who are just getting started, and they're blown away by your project, and when they want to make something similar, how do you recommend they get to that, jump the gap from notebooks and documentation
Yeah,
to a small little thing that runs perfectly?
yeah, that's the key question. I really like that you mentioned this. So for me, at least, this is my personal experience, like my personal journey. I started as a data scientist, and I was really confident when I was working on a Jupyter notebook, and then I had to make the jump and see what happened. For me, the key ingredient is to focus on just one project that you like to build. Like, for example, this one. Suppose you want to build this twin celebrity app. Then for 1 month, maybe, just focus on this project and try to learn all the specific technologies that you need for this project. And you might, it's not necessary for you to reinvent like the wheel. You could take the Twin Celebrity app and do the same, but in Azure or in Amazon, for example. Or use a different like Kedro instead of ZenML, or change anything that you want and choose the technologies that you feel confident with. And for those technologies that you don't feel confident with, just learn how to do it. And not learn by reading tons and tons of documentations and watching thousands of videos, trying to implement things and just learn the bits and pieces that are missing on your development. That's at least that's my advice. Like, to build something by building. Learn things by building, and when you realize that you have built like 3 or 4 high quality projects, end to end projects, you will realize that you have made a huge jump, like a huge improvement, and
Taking a
that's
big
something.
bite, taking a
Yeah,
big bite can be discouraging at times, but making small calibrations can give you that momentum to keep going.
that's it. That's
Yeah,
it.
it's kind of
Yeah, that's it.
psychological in a way as well.
Yeah, it's psychological, 100%. And for all of those who are starting in machine learning engineer, they need to be very careful with not getting themselves be driven by FOMO, fear of missing out, because right now Twitter and LinkedIn, etc., is filled with a lot of people like posting the new article, the new rack technique, the new etc.
Yeah.
And I understand that it's like generates a lot of anxiety because you want to be aware of everything. But this is a piece of reality. Like no one is aware of everything. I mean, we are all trying to build our stuff. And for example, if you ask me about the last LLM that has been deployed or the last RAG technique, I wouldn't know it. I
No.
mean, and it's perfectly fine. I mean, it's perfectly fine because at the end of the day, we want to build ML products or AI products that work and that bring some value to the users and to the customers.
Yeah,
And that's it.
I was at a conference in Silicon Valley about a month ago. This is the same story. I mean, we're dealing with experts from organizations like Intel, Oracle, AWS. I mean, these are very highly experienced people, and they're just saying we're blown away. I mean, we can't catch up to all the news that are
Yeah,
coming out. It's too much. It's too much for
yeah,
everybody. So definitely, good advice is to not get caught up in it and just focus on creating a stable project, small
that's it.
bites, and moving forward. And that's good enough for the beginning, and ultimately it'll lead to a huge body
That's
of
it.
knowledge down the road.
Yeah,
Yeah.
I'm I'm very up to that philosophy. Yeah, I love that.
But you have another project that I you may want to talk about, which caught our attention months ago. This one is a little tougher. It's
Yeah,
called
much
Quadrant
tougher.
Kart. Can you tell us
Qdrant,
something?
yeah, yeah, Qdrant Kart. Yeah, let me share the screen one more time because it's much simpler this way. I couldn't post the code because it's composed of 5 different containers, and it's not easy to implement. But yeah, I think it's funny. The end product is really funny. So yeah, as you mentioned, David, this is the project Qdrant Kart, and it also has like one batch block and one real time block. But the end goal of this project is basically to play Mario Kart 64, which is one of my favorite games, just using a vector database. Okay, and if you take a look at the batch block, you will see that it's very similar to the vector twin because I'm applying the same principles but for 2 different domains, and that's really cool with embedding applications because you might be creating a recommender system or a vector twin or a Qdrant Kart, and the approach is basically the same. In this case, I'm taking a lot of screenshots every 200 milliseconds, I think, of my Nintendo 64 emulator playing Mario Kart, and I generate embeddings for each screenshot. In this case, I'm using VGG. It's one of
Okay.
the typical convolutional neural networks, historical ones, and I'm using that one to generate embeddings. And at the same time, I'm going to attach to each one of the embeddings the buttons that I was pressing at the time. So if I was pressing A and the joystick was pointing to the left, then I will record everything
So this
every
is the
200
metadata
milliseconds.
attached to the
That's
vector.
it. That's it. The metadata in the payload to the point. Yeah, that's it. And I'm storing all of that into Qdrant. So as you can expect, since we are taking, I mean, races in Mario Kart, some of them are really long, and I'm taking a screenshot every 200 milliseconds. There are a lot of images, so there are a lot
Yeah.
of images that I need to transform into embeddings and store into Qdrant. And then in the real-time phase, this is the most difficult one. I need to take the current screenshot in the video game, convert this screenshot into an embedding, fetch similar embeddings from Qdrant, and get the most similar screenshot from the past from the vector database. And then get the metadata from that similar embedding and apply these buttons to the video game. And this is something that all of this Nintendo 64 emulation, I've taken it from a project from I don't know 7 years ago, I think, which is called Tensor Card, which I find really interesting. It was developed by a guy named Kevin Hughes, and it's amazing. I mean, it's an amazing project, but he was doing everything with a TensorFlow model, and I wanted to make it work with just a vector database, and that's basically what I did. I created a Medium post covering everything, and you can see here the vector database in action. So every line that you see there in VS Code is one read from Qdrant. Every
Yeah.
200 milliseconds is reading for Qdrant and taking the similar embedding, etc., etc. So it really surprised me how efficient is Qdrant in all of this and how fast the latencies were amazing. But yeah, you can see that more or less it's doing like an amazing, like a good loop. I mean, it's turning left when it has to, etc. And here in the Medium post, I have all that I have covered here in 5 minutes in a long post. Yeah, and you have everything. Oh
You
no,
know, it's
it was ResNet 50, not VGG. It was ResNet 50, the
and we're
model.
going to link to this post as well.
Cool.
But it's interesting, the first example with the facial recognition was about precision. This one is about capacity.
Yeah, that's it.
The sheer amount of vectors you can put into the database and the way you can search over all that information is we like to see that. That's why we're so happy to show it off. This one, I don't know if all the vector database add-ons can handle the same way. I think this one is you need to have a pretty custom built vector DB for
Yeah,
this to work.
yeah,
So
that's it.
yeah, we like this use case for that reason because it shows off kind of the extremes that you can stretch vector search to.
Yeah, yeah, yeah. I was amazed by the speed. Yeah, yeah, it
Could
was
you
really cool.
could you tell us a little bit about your future projects and what you're looking to do after are you doing any kind of stuff like this, or are you gonna do something else in the coming year? What do you have lined
Yeah,
up
yeah.
25?
Yeah, I have a couple of projects that I would like to build, and two of them involve probably will involve Quadrant as well. One of them is about a recommender system. In fact, I'm currently building, like wrapping up all the pieces. I would try to build Spotify from scratch, like try to teach people how to build a recommender system like Spotify, like Recommender Weekly, for example, and try to deal. I have dealt with images in this case, but I want to do the same with audio, like transforming the audio into spectrograms and then generating the embedding of audio, and try to incorporate all of this audio information in addition to the I don't know the band information, metadata, etc. about the song, and in this sense try to generate a song recommender. That's one of the projects I'm currently working on, and the other one, which is something that I need to figure out a little bit how to implement. It's something similar to the movie Hair, like Joaquin Phoenix and Scarlett Johansson, trying to build something like an AI companion using a vector database as the long-term memory. It will be like an agent where I will store all the past conversations with you, because I want this agent to be able to remember that you tell him about your dog being sick 3 months ago, all of this long-term memory, and also defining all the personality with a fine-tuned model, and also with a rack strategy where it can fetch relevant pieces of information from the memory. So yeah, those are the two projects I'm considering. One is has started, the recommender system, and the other one I will need to wrap some bits and pieces.
For the first one, will you be using the recommendation API with the positive and negative context, or will you just
Yeah,
be doing regular search?
no, I'm considering. Yeah, I like the positive and negative. Yeah, I
Yeah.
like that, the recommender API. Yeah,
And then for the second one, I assume it'll be used as some type of a cache to retrieve
that's
similar
it.
responses and same responses for at a lower kind of
That's it.
expenditure of resource as well.
Yeah, that's it. That's it.
Yeah. Okay. Well, we're gonna have to be in touch because I really like your projects. Um, I think everybody in Quadrant shares it in Slack all the time. They're very
Cool.
excited. They're easy to
That's
figure
great.
out. I think that's great for not just beginners, but anybody.
That's
Um,
great.
and the fact that they're so cleanly organized, the architecture makes complete sense, and the choices of each piece and each tool is very carefully done. We really like all this stuff.
That's
So
great.
I think what we're gonna do is end it here, and we're gonna
Nice.
share all of the links. We're gonna share links to your profiles and as well as your project so that people can check it out. And
Cool.
possibly we'll be authoring something on the website as well. Something later this week. I'll try to push something to our blog.
Nice. Sounds perfect.
Miguel, thank you so much. It was a pleasure, and we'll talk soon.
Okay, the pleasure was mine, David.
Bye.